This video is to talk about the inverse functions for the sine, cosine, and tangent, so arcsine, arccosine, and arctangent, and then give some examples that illustrate some of the concepts. So the first thing I want to talk about is what these expressions actually mean. So when I say that the arcsine of some number equals some angle, that's just saying sine of that angle equals x. So what does arc sine of x mean? It is the angle that when you take the sine of it, you get out x. They're inverse functions. Switch input and output. X is in, theta's out. Down below, theta's in, x is out. But it means more than that. It means one more piece. Because sine theta is not a one-to-one function, there are many numbers, many angles that give the sine of that angle equal to some value. And so what we do is we say, hey, not only is sine of theta equal to x, but theta is in the fourth quadrant or the first quadrant. Theta is between negative pi over 2 and pi over 2. And similarly, our cosine of x equals theta means that cosine of theta equals x, but this other deal is that we know that theta is the angle whose cosine comes out to x, but it's the angle between 0 and pi. I'm in the first quadrant or the second quadrant. And then finally, arctangent. So I'm going to try to illustrate what these are saying with some examples. So the first example that I've got is to try to see what is the value of the arcsine of negative square root of 3 over 2. The first thing is I kind of recognize negative square root of 3 over 2 as a special output, so I'm hoping that just with the unit circle, without a calculator, I can figure this out. And so first thing I do is I go, okay, so arcsine of negative square root of 3 over 2 is some angle. And it's the angle, theta, that when I take the sine of theta, I get out negative square root of 3 over 2. But not only that, I know that it's the one that's between negative pi over 2 and pi over 2. So I start thinking about this. I go, okay, so negative square root of 3 over 2, so that's pretty big. That's down here. Negative square root of 3 over 2, and I must be negative pi over 3 to make that happen. All right, next example. Next example, I'm looking for the arc cosine of negative 1. So this is some angle that when I take the cosine of that angle, I get out negative 1. But not only that, I know that my angle is between 0 and pi. So I look at my unit circle and I go, okay, so the x coordinate is negative 1. Okay, this must be pi. This must be pi. And so my final example, arctangent of 1, this is going to be some angle that when I take the tangent of that angle, I get out 1. But not only that, my angle's got to be between negative pi halves and positive pi halves. So I go to my unit circle. Tangent is sine over cosine. It's the y over the x. Another way to think of it is that it's the slope of the line that connects my ordered pair to the origin. So if I'm going to have slope 1, I've got to be right in the middle here. And so I must be here at pi fourths.